introduced officially to the A, H, and K crowd. Now, what I mean by that, and I'll explain it here in a second. Remember, absolute value just means distance from zero. And as you start to think about how you guys all learn to graph, the first way that I think just about every teacher always shows how to graph is to make a table. Remember that? And usually what we did is we would pick values of x on both sides of the of zero. A lot of times, I always was a strong advocate of doing -2, -1, zeros, ones, and twos. I think most of you guys saw that because that way you're seeing what's happening on one side of the axis and what's happening on the other side of the axis, so you get an idea of what's going on. So when you do something like that, it turned into a basic plug-and-chug style problem where you just substitute in values and getting the answer. Absolute value doesn't change. Just remember, how do you find the absolute value? Well, what's the absolute value of -2? 2. What's the absolute value of -1? Absolute value of 0. Absolute value of 1. And the absolute value of 2. All right. Whew. That was tough. Congratulations, you did math. What's that? Never again, yes. Never forget. So now, do you have ordered pairs? Yeah, you just plot. Okay. This is how you guys all learned how to graph. You learned to graph via tables. What do you think occurs past those dots? They just continue. They just continue, and it creates a V. Absolute value graphs create V's. I see what you did there with the V. Very interesting. It's going to be a rough year. So when you have these absolute value functions, what's happening here is they become symmetrical about kind of like, what do you call those things? Parabolas. I forgot what they were called. Remember how parabolas were symmetrical about the x-axis that we had? The vertex, the x-coordinate? This is kind of the same idea, except it's linear, not quadratic, so it's not curved. So by being a linear function here, you get this, what we call a pseudo-axis of symmetry, where all of these points are going to be the same distance to that vertical spot. That vertical spot is kind of what we call the vertex. Okay? This is a parent function. This is what we call this a parent function. The reason we call that a parent function is because it starts at the origin and it has a standardized, well, in this case, a slope of 1. What happens after this is that we can take any standardized function, if you will, and we can move it. What I mean by moving it is that we're going to move it horizontally and vertically, this H and K, the horizontal shift, the vertical shift. No, that's a stretch is when you have a scalar to it. That's when you do stuff like this. Yeah.
You can't do it with paper.
You get this. This is the shift. This is a shifted form of a generic equation of the absolute value. I kind of told you guys that throughout the course of the school year, you're going to see this A, H, and K pretty regularly with every single graph that we do. There's going to be a basic graph, and then it's shifted form. Now, what's nice about shifted form and parent function stuff is that you don't need calculators to do any of this. Because if you know what the parent function is, you know what happens in each set of those ordered pairs, they're going to get moved horizontally and vertically, the y value. It's dumb, but you're never going to forget that because what comes first in the alphabet? Horizontal or vertical? I'm sorry, horizontal, horizontal or vertical. I forgot what this is. H, what comes first in the alphabet, X or Y? The X values go left and right because they're part of the H's. The K values are part of the Y's because they go up and down. Hence why I say vertically. You know, there's a C in it, but it's just one of those. Yeah, it's one of those mnemonic devices things. It's like singing the quadratic formula song. I got a great video that I'll show you guys too about it. So this idea of parent function, whenever you see this parent function, it's x minus an h plus a k. This ordered pair hk is where the vertex is going to lie. So if I have a generic equation, or excuse me, a shifted equation that looks like this, y equals, let me change the color, green doesn't show up very well. Y equals 3x minus 2 minus 4. That means that I would start that graph at the vertex of 2, negative 4. Okay. This part, I wouldn't really so much worry about what's going on with that, because really all it winds up being is slope. The a value is the slope. Okay. If the a value is positive, you know that you're going to have to go up and right from the vertex, and then you have to go up and left from the vertex to make it symmetrical. If the a value is negative, you would first go down and right, and then you come back and go down and left, just to mirror it. Okay. Think of the a values in this case as slope, because that's what it is. Okay. So you have to worry about how much it's going to pitch. It'll make sense when you see numerical value. So this example has an h and a k value at 2 and negative 4. Remember, just like point slope form, you had that y minus y sub 1, x minus x sub 1. Whereas if your ordered pairs were 3, 5, it would have been, y minus 5, x minus 3. But if it was negative, change the signs to pluses. Okay? You'll see that a lot. It just takes a little bit of time to get used to it if you have forgotten at some point. Okay? So if I'm looking at that generic graph, that 3 absolute value x minus 2 minus 4, might as well just show you this example now. This time, right? So where do you start? You start at 2, negative 4, right? 2, negative 4 is your vertex. And what's your slope? 3. So I start plotting from that spot. Up 3 over 1, up 3 over 1. Bless you. The opposite of up and right, well, I'm sorry, to turn it the other direction would just be up and left. Bless you. There you go. Quick and painless. Absolute values are a little bit easier to graph than those piecewise ones. A little less work involved. A little less work. You guys are much harder than 12 hours. Thank you. Still,
It's like how you're louder first down.
yeah. Let's try this one. Let's do a negative one. Might as well. I mean, you're stuck here for another 26 minutes, so you might as well do something. Yeah, don't be surprised when we get to the test stuff on Friday if there is calculator non-calculator, because obviously you could press buttons all day long and just get your table and plot points. I won't let you do that. So you know. Yes, sir. Yeah. For this one? Oh, I'm sorry. For this one? Remember, it's x minus h. So if it's x minus h plus k, the ordered pair is h, k. All right. Does that make sense? That's fine. Where do I start this one? 2, -3, good. And your slope is? So I start at 2, -3. Being negative means which direction is this going to open? It's going to open downward. Just go down 1/2. Down 1/2. And this is where that idea of the absolute value of A, if it's less than 1, see how it's wider? How it was greater than 1 earlier was 3, it was narrower. That's because the slopes were increasing at a greater rate. Okay, that's, like I said, yeah, it's not a really big end of the world idea. If you understand it, it's going to be narrower or wider. You're still going to walk the slope anyways. Real difficult stuff today. All right, try this. Yes, ma'am. What do you mean? By intersecting wise? Does it? Oh, through all these points? Yeah, they do. Yeah. I try to draw this as cleanly as possible. Where's the vertex? 3, 1. Good. What's your slope? -1. So all this is sometimes you just see it written as negative absolute value. You don't put the 1 there. Save in ink. Get better with the high fives.
Oh, wait, I can do better.
I had a kid, I did once give her a high five, and she missed. Seriously, she's right here. Do I need to do more of these? There are 4 graphs and then 6 right at the equations. The graph paper you had yesterday, you should have space on it still, right? So just add to that. That way you know where all the graph stuff is at for right now. And then just fill in through there. If you give me a second, I will put, I don't think I put the PDF file on the calendar quite yet, so pop it on here real fast. And then that way you guys have that to go. Otherwise, if you want, here's a textbook. If you want to take a picture on it, it's right on that page while I upload the PDF file.
Oh, I did my homework last year. Oh my god, so apparently, and stuff. That's out. You could like write calling themselves because like she said, we're dumb if you can't because like you did wrong. Like, no, that's okay. And like, it's not like I really like way heavy. I mean, like other people, like I can't see if it's good for like. I like I can't see whether it's.
If you guys check the calendar now, you just updated it. Let me know if it does not work. Good? All right. What's up, Sarah?